Hello, I am Professor Carl De Bono from the Faculty of ICT. I'm currently the Dean of the Faculty, and I'm also a member of the Department of Communication and Computer Engineering. And today I will be discussing with you a project that we are working in order to support active aging and the well-being through the use of technology. And the work that we are looking at today is supported by the NATIFLife Project, where NATIFLife stands for a network of assistive technology and for an independent and functional life. It is funded by the European Regional Development Fund through the Interreg 5A Italia-Malta program, and therefore we have also colleagues from Sicily that are partners in this project. Okay. However, today we'll discuss only the component done by the University of Malta. Now, if we look at demographics of the European Union, okay, we see that today we have a longer life expectancy, and this longer life expectancy is leading to a steady increase in elderly population that would need daily support. Okay. And now this support can be obtained either through private elderly homes, right, or through government elderly homes, as the younger generation most of the time cannot take care, right, of their elderly. Okay. Therefore, assistive living systems come into play over here as they can support elderly people to remain longer at their homes. Okay. Now, this has been proved to provide a better quality of life as the elderly keep on living in their environment, right, together with relatives and friends close by. Now, the work that I'm presenting today is based solely on the depth information, which is the information we get from stereo cameras, and it represents the distance between an object or a person, right, from the camera lens. Now we are using this depth information instead of the color video to provide a better sense of privacy to the user, okay, because the depth information, right, only shows us silhouettes of the persons. Okay. The position information that we obtain after processing the depth data is stored in the network. And because we have position information with time, okay, we can use this information to understand the behavior of the person and take any action if needed. So this can be viewed remotely either by the carers or by family relatives, okay, to understand that the elderly are doing their normal chores. So the concept, as you can see on your right hand side of the screen, okay, we have a user, a person, right, that is moving in the indoor space, right, and we are installing these cameras to monitor the person, okay, by detecting the person and then tracking the motion as we have these locations with time. Okay. This information, so the depth information, is captured, stored, well, not even stored, right? It is processed at the at a computer within the living space, right? And only the position information is sent to a database, which is stored, right, on the network, such that it can be accessible by the carers and by the relatives. So a prototype can be seen over here. So we developed a prototype at the university, at the Faculty of ICT, in one of our labs. And so on your right-hand side, you can see the captured information, which shows only the depth. And you can see the silhouette of the person moving around. Right at the bottom of the screen, center bottom, you can see the point cloud generated from the data, right? And we are seeing the points, right, represent the track of that the person goes through. Okay, so we are seeing how the depth information is used to gain, okay, the tracking system. On the prototype, we can see, okay, that we can both monitor what is happening, right, on a smartphone device, right, and on your right, we can see that this can be also be seen, right, on a computer platform. Okay, so we can monitor either on mobile devices, right, or on fixed devices. Now, what is important to say here, right, is what the end application will receive, right, are the dots that show the track where the user moved. Okay, so that those are the dots that we obtain, right, and those will be superimposed, right, on the floor plan, which is obviously the house where the elderly lives. Okay? We can see that the system is also capable of tracking more than one person, right, at a time. So some results that we obtained, we achieve an average accuracy of 66.5%. Okay, we did this by looking at some test cases, right, which included random walks, opening and closing of furniture, sitting on a chair, laying down on a sofa, right, and even simulated a fall. And we saw that the maximum detection accuracy using a machine learning algorithm, so using some AI, reached an accuracy of 86.61% when the person is walking. The tracking accuracy that we achieved was 59.1%, right, with the maximum accuracy occurring also for random walk at 85.7%. Now we saw that the accuracy of tracking is correlated to that of detection. So if we are able to detect the user, okay, the person, we get better tracking accuracy. And we saw that the accuracy also depended on the accuracy of the depth data. Okay, so better depth data achieves better accuracy. Okay, so for example, when the user fell on the ground, the user was lost in some of the frames, okay, because of the user was too close to the ground plane, right, and was not always detected as a user. So thank you for your attention. Okay, if you have any questions, you can contact me on the email shown.